Good morning. Today I will start electrical systems used in submersible pump. So before we go to electrical system, let's see from surface to bottom what are the different equipment available for ESP electric submersible pump. So first surface you draw, then from surface you are going to your downhole area or reservoir area. Okay. So this is my reservoir, I assume. Okay, there will be perforations, okay, and this also cemented, this side, both sides. So this I got a hole. Now I will have one tubing. Okay, so I'll remove this one. I'll draw like this. Okay, I'll got one tubing. So tubing will be passing through one. Okay. I will not draw like this, I will draw like this, then this will go like this, this will go like this, tubing is going guys, going out. Okay, so this is tubing. So actually it will be passing through tubing hanger, tubing will be there, tubing hanger, there will be one Christmas tree here. Xmas tree will be there. This is tubing, this is casing, already you know this. And submersible pump, if I put electric submersible pump, then one cable will come from surface, it will go to motor. Okay, this is my motor, then motor to one protector section, protector, motor protector means it is a seal section. This will be making safe. Motor must not get wellbore liquid inside it. It must have some dielectric fluid inside, and protector will be protecting the motor, and motor shaft will be passing through the protector and it will go to pump. Okay, so pump should have lots of impellers. Okay, this is my pump. Okay, now from pump fluid will go like this, wellbore fluid you are sending like this. Okay, and in between there will be one section called gas separator. There will be one gas separator. Okay, and electric cable somewhere it will go out, or then it will go to one junction box. It will go to one junction box. Okay, then junction box it will go to switchboard, TCH switchboard, then switchboard 2 it will go to transformer, transformer will be connected to your 3-phase high tension line. Okay, so this is the basic feature. I am not showing details part of wellhead and Christmas tree part, because already we discussed. Now today we will see the electrical part. Electrical part includes the transformer. From top if you see transformer to switchboard, switchboard to your junction box or vent box. Then from there the cable will be entering into wellbore and it will be directly connected to motor. Okay, so motor will take electricity from the surface and it will be rotating on shaft. Okay, the shaft will be passing through your, this is shaft, SHFT. Shaft will be passing through your protector section, then gas separator section, then it will reach to pump or impellers. Lots of impellers will be there, impeller, diffuser. So pump will get power from motor in terms of torque. Okay, so torque will be the torque will be transferred by shaft. Shaft is connected to your impeller. So impeller rotating, that time fluid is getting lots of energy, it is getting velocity increased, again diffuser velocity reducing, increasing, decreasing. So this way fluid will be moving up and it will get lots of pressure or head. Okay. This way the whole submersible pump will be working. Now, we will go to electrical part. So, basic formula VIP. So, V is voltage, I ampere current. Okay, voltage or potential difference, and I means ampere means current, P means power. Okay, so V equals I R, R equals resistance, resistance equals R, P equals V I. Okay, normally unit will be watt, and if you divide by 1000, then it will be kilowatt. Okay, and H equals I square R T, H heat generation. Okay, if it is producing heat, then formula will be I square R T, T is time, how much time it is carrying electricity, based on that heat will be generated. This heat generation also important, because motor is getting electricity, electricity will be, some electricity will be lost, 100% electrical power cannot be converted into your mechanical energy, because mechanical energy conversion happening electrical to mechanical in motor. Now, when you are converting, some energy will lost, then where the energy will go? So, energy will be lost, it will be increasing entropy or heat, final form of any energy is heat, and wellbore, it is fixed dimension is there. Okay, fixed dimension is there, and continuously if heat is getting generated, then temperature will be increasing at that area. Okay, if motor temperature is going beyond certain limit, then your insulation will be having problem, lots of elastomer seals will be there, seal will be having problem. If seals are having problem, insulation is having problem, then motor will get wellbore fluid. Okay, so inside motor there will be one dielectric fluid. Dielectric fluid means that will be creating as an insulator inside motor. Later we will discuss what is dielectric fluid. So, that dielectric fluid will be replaced by your wellbore fluid. Wellbore fluid will not have that much property whatever dielectric fluid is having. So, what will happen? You replace dielectric fluid by wellbore fluid. Okay. So, whatever purpose was there for your dielectric fluid is lost. Now, there will be internal spark inside the motor. So, because of that, whole motor system or electrical system will fail. So, that is why you have to seal it properly, and you have to put dielectric fluid, and you have to maintain proper pressure also, so that wellbore fluid or outside fluid like oil or gas or water should not enter into your motor system. Okay. And if heat generation is high, then whole system will burn, and you have to remove the heat. How to remove the heat? When fluid is flowing, pump is on, fluid is flowing, that fluid will take, or water or oil will take the heat and to the surface, and if it is running, let us say motor is running, but your impeller is not working and it is not delivering fluid. So, heat will be accumulated there. So, temperature will be going 100 degree centigrade, 200 degree centigrade, 300 centigrade, finally it will fail. So, whenever pump is motor is working, but pump is not running, so that time actually you should switch off, it will check the problem and it will solve. If you are not switching off, then finally motor will get burned and your whole system will get destroyed, and you have to replace it, and that will be expensive affair. Any artificial lifting system not working, and you want to replace the system, it will be expensive affair, I already told I think in previous lectures. So, you have to avoid that sort of problem, so that your system will be giving longer life, longer time of production, with stable production. Actually you cannot change the production rate. Okay, you are getting stable production for longer period of time, it will be more economical. But if you need more frequent servicing, like say problematic wellbore will be there, frequent service will be required in such wellbore. So, there will be more expensive. Okay. So, you have to avoid heat generation there inside wellbore. And we will discuss series and parallel connection, motor cable pot head. Pot head means like electric cable is coming and motor is there, somewhere you have to connect, and it is submerged in liquid, and if your connection is having some problem, then water will enter into the system. When water is entered, gone. So, you have to make that connection properly. So, connect it, it will never get any water or outside fluid, so that there will be no sparking or insulation issues. Protector, I already told that it will be protecting your motor. There will be some bearings and seals inside protector. I mean, bearings will be there in your motor and your pump or impeller systems. Junction box will be on the surface, switchboard, variable frequency drive. Variable frequency drive actually to be changing the speed of motor. So, that also be part of switchboard. heat generation calculation will show at the end. Now, voltage current analogy, analogy to fluid flow. So, if I am assuming this is fluid flow loop, this is electricity. Okay. So, you can say fluid flow energy or electricity energy from one versus another. So, initial fluid flow loop pressure is here P 1, maybe this is P 2. So, pressure difference is P 1 minus P 2, okay, del P. In my case voltage difference is here, okay. So, pressure difference actually your EMF, potential difference, that is volt, and you have resistance here. Here one valve is there, or restriction you are creating. So, resistance is restriction when electron is trying to flow through a wire. So, if it is getting resistance, that is called resistance, right. In fluid flow what we do, you have long pipe and you create one narrow section or one valve we create, so that fluid will get restricted. So, less fluid will be flowing. So, there will be lots of pressure drop, and resistance also will have voltage current drop, okay. So, okay, and there will be like switch will be there, and there will be also valve, controlling valve will be there. So, that way you can compare actually. So, flow rate will be current, same, and voltage V del P it will be compared to as a pressure difference, okay. So, if you know fluid flow, then you can understand electricity, or if you know electricity, then you can understand fluid flow based on this concept actually. So, if you compare like this volume, if you then compare electricity, then it will be charge, mechanical momentum we say, flux. If we compare, so volume flow rate is can be considered as flux. In electricity it is current, and mechanical system is velocity. So, flux density, let us say volume flow rate Q by A, volume V is volume, and V. So, current will be I, and stress will be sigma. Potential difference pressure del P I already told, it will be volt, right. EMF potential difference, then force F, okay. This way you can compare. So, it will be easier to remember actually. So, power I already wrote, V I equals power W or P, whatever you write, V equals I R, resistance, okay, resistance rho into L by A, rho is resistivity, okay, and different material will have different resistivity. L is length of a conductor and A is the area. For example, if I have conductor like this, and this is L, okay, copper wire I take, and this area of cross section A, then resistance will be R equals rho L by A, okay. Now, some material will have very low resistivity, for example, copper, some will be very high resistivity, wood or plastic, very high resistivity, that means that we used as a insulator, but very low resistivity means it can be used as a conductor, okay. So, conductance is just opposite of resistance. So, G actually 1 by R, okay. So, it will have sigma AL by A, G equals, okay, G equals sigma L A by L, opposite of R, okay. This is called electrical conductivity. Sigma is electrical conductivity, you can see here a definition also I have given here, okay. And if it is resistance is temperature different, resistance is temperature dependent. So, in many cases if we increase temperature, resistance also will increase. What happens when electrons are moving and you are increasing temperature, so electron will be colliding each other, okay. Because of collision, your electron will not be flowing as fast as it was in lower temperature, okay. So, you increase temperature, resistance will increase. That is why this term, this formula is coming, R T at certain temperature 1 plus alpha O T. T is temperature, alpha is your at certain degree, at 0 degree centigrade, what will be the resistance, okay, multiplying factor. And for motor, if you are calculating, later we will discuss this one also. In a synchronous speed equals 120 f frequency divided by number of poles. This is a motor speed. Motor speed is especially for induction motor. Okay. For induction 3-phase motor, probably this will be the formula. P is the 4. Okay. Frequency it will be unit will be hertz per second. How many frequency you are finding, that is a hertz actually. Motor slip is S equals N minus N by N2 by N2 or some other term also you can use. N actually motor synchronous speed, and if you load it, let us say initially you switch on motor and you do not connect any load, you do not connect to pump, artificial lifting system, ESP or anything, then motor speed will be very high. Now you connect to ESP system, it is pumping, so because of this extra load, motor speed will be little bit reduced. Okay. So that means initially it was efficiency, let us say speed was 3600 rpm, after loading 3500 rpm. So what will be slip? N means 3600 minus 3500 divided by 3600. So it will be converted into 100, and this will be a slip. So 2%, 3%, 4% slip will be there in every motor. And normally ESP system 60 hertz, if I have 60 hertz motor, so speed will be synchronous will be 3600, and after loading it will be around 3500 speed. So 3600 minus 3500 divided by 3600 into 100. So this way you can calculate amount of slip, percent of slip. Okay. Okay. I already know the conductor used for your ESP cable. So electric submersible pump will have junction box, cable coming into wellbore to motor. Okay. So the cable is very long actually. ESP motor will be installed, let us say to 2000 feet, 3000 feet depth. So that means 2000, 3000 feet long cable will be there, 1 or 2 kilometer, 3 kilometer long cable. So long cable means lots of electric losses will be there because of resistance, because you have seen R equals rho into L by A, right, this formula. So L is increased, means resistance, total resistance also increasing. And how to reduce the resistance then? Resistance means pressure drop in fluid flow, but here your voltage drop or current drop, right, voltage drop. So voltage drop, so how to avoid? Here this formula says like area you have to increase, A increase, L reduce, rho reduce. Okay. So L you cannot do anything, A maybe you can change, but A or area of conductor will be limited because you have specific tubing size and casing size, and if your cable is entering through tubing casing the annulus area, then that area will be limited. So you cannot increase conductor size whatever you like. So you have limitation of conductor size. Sometime if area little bit high, then you can use circular conductor, but if area is very low, then maybe you can use flat type conductor. Okay. So area also limited. So you have only one option, rho changing. Rho changing means material changing. Material changes, which material will have lower resistivity, lower resistance. Low resistance, here you see the table, these are the lowest actually. Silver, copper, aluminum, maybe gold also possible, but because of economical reason you do not use gold or silver, other people will be taking away instead of putting into wellbore. So you have two options, aluminum and copper. Okay. So most commonly used conductor is copper, some cases aluminum also used. Okay. Copper is having lots of free electron on the surface, material is there. Okay. So electron, every atoms will have some free electrons. So free electron easily can move from one point to another point. If you apply small potential difference, electron will be trying to moving from one, they want to play actually as electrons. So apply small potential, small energy you give, so they will be running actually positive negative pole. So copper waste normally they will be using either single solid configuration or multiple small configuration. If you see this picture, this is single solid configuration. Single solid configuration means only little bit thicker wire is there. Okay. But if you have multiple also possible. Okay. Multiple is more flexible. So that's why people use multiple, and electrical current conducted by a surface. So multiple will be better in terms of electricity conductance also, but managing also very difficult. If it is getting cut, then one wire can be going out. So that sort of management also one issue for multiple strand, but very those are multiple strands are very much flexible actually. Solid conductor, smaller and easier to clean spices. Solid conductor means only single wear is there. Smoother surface, less expensive. Stranded cable mechanically flexible. You see this multiple wears are there, mechanically flexible, but problem is that void, small gaps will be there. Like say one wear is here, one wear is here, one wear is there. So this gap will be carrying gas. If there is any way wellbore gas is entering there, so the gas will be coming up to the surface. So that gas will be very much inflammable. That will be very much problematic. Okay. So that's why you need gas vent junction box on the surface. Stranded cable mechanical flexible, voids in the strand are filled with gases, migrate up or down to the cable more easily. Okay. The copper conductor tinned or coated. Copper conductors, if you are not coating properly, then it can get oxidized and life will be lower. So they will be coated. Okay. Lead alloy insulated with, again it will be insulated also, like two wears are very close. If you are not insulated, then electron can passing from one another, so that will be one biggest problem. So that will be they will be coated properly and insulated also. Rubber insulated ESP cables use bare copper conductor. Okay. So here I have given the definition: braided wire, multiple strand of flexible wire wound in a spool or circular pattern around a core. Okay. So around a core it will be multiple strand will be there. Okay. So this is called braided wire. Rated motor torque, this one. Okay. Okay, motor power, how to calculate? P equals T omega. So when motor is rotating and it is consuming certain amount of power, say 100 kilowatt power it is using, and what will be the RPM? You can calculate actually how much torque it is producing based on RPM. So the formula is like this: if I have a synchronous speed, let's say 3600 RPM. Okay. So what will be the omega, angular velocity? Angular speed will be 2n pi by 60, and power equals T into omega. T means torque. Okay. So if we know torque and RPM, then you can calculate power, or if we know power and RPM, so vice versa you can calculate other. If two parameters are given, third parameter you can calculate. So conduction, already told that it is means low resistance. Insulator means there is no or almost negligible free electron. If almost negligible free electron is there, so whenever it is covering any copper wire or any silver wire or any aluminum wire, the electron will be passing through this. Okay, passing through the material. So electron is not passing through the material, means it will be calling as an insulator. So it is insulating. Okay, electrons are not passing from each other. So all the electrical wires, normally it will be insulated for safety reasons. Safety reasons, plus two cables should not touch each other, and it should not create spark also. Because of that reason also they should be insulated. Okay. So we know the conductor means free electron is there, electron is flowing, running, playing, but non-conductor or insulator, free electrons are not there. So there will be no electricity conductivity. Semiconductor, another term you are you know that, electrical resistance between metal and insulator. In semiconductor, normally doping material will be there, and they will be changing electrical properties. Again it will be temperature dependent. For example, your computer is there, temperature is becoming high, then performance will change. Thus a computer will have one fan, you can see this, it will be reducing the heat generation. If heating up more and more, then your computer performance will be down. Sometimes insulation problem will be occurring. Insulation means at very high temperature semiconductor may not work, or your insulation softer material, rubber or polypropylene or some other softer material, those will be melted and it will create leakage in the system. So two wire can come together, they can burn, and you can find smell of burning plastics or rubber. Electricity and magnetism. Okay. So these are very basic actually. If you know already basic electrical engineering, this is fine. If you do not know, please recap. Okay. And electricity creates magnetism, or magnet produce electricity. How? And because of this phenomenon, actually you are generating your generator or motor your household induction heater you are producing, and here we in my laboratory, wave energy laboratory at IIT Madras. So, there we produce electromagnetism and for wave energy production. Okay, this is one electromagnetic system I used in my laboratory. If you see this video, okay, it is having one vertical magnet, actually magnet is here, okay, and coil will be around, coil is wrapping like this. Okay. When magnet is moving up inside coil, let us say I have one magnet here. Okay. If I move magnet inside coil, so magnet will be creating EMF, and that EMF is being sensed by my this one. Okay. So, you see this again, my system is running, and here a digital meter, it is showing some digits changing here. Okay. It is showing that it is being electricity is being produced, but this basic mechanism, this one actually it is wave energy device. Wave energy means water is moving up and down, and my magnet is fixed almost in vertical rod, and my coil is moving up and down. Okay. Coil is connected to this black vertical buoy. Okay. So, when coil is moving up and down, okay, coil is here, my magnet is here. Okay. Magnet, coil, this is called solenoid also. So, when coil is moving up and down, magnet is having its own magnetic flask. Okay. Okay. Now, because of this coil movement, my electricity is going there to digital meter, and I can see my digit 7, 8, 4, 5 whatever is there. Okay. So, any coil, when you are giving small electricity, it will create magnet. Okay. Or if coil is here, the magnet is moving up and down, magnet is creating lots of flask. If magnetic flask is surrounded by coil, so coil will get EMF. Okay. When EMF is getting there, you are sensing here. So, two things, one thing is that when if coil is there, you are passing electricity, you will create magnet. Next thing, if magnet only there, it will create only flasks. When both flasks are getting cut, so that will be producing EMF or electromotive force. Here my simple system, it is showing that it is producing electricity. So, it is there in market also, like if you buy solenoid system, a move magnet like this, you can get electricity. So, this is a linear magnet, linear generator, linear motor concept actually. Phi by A, B is magnetic inductance, A is the area, and phi is the magnetic flask. Okay, it is like this. If I have one surface, and how much flux is crossing through this perpendicularly. So, this is area, okay, and this is magnetic flux phi. So, inductance will be phi by A. Magnetic field intensity, magnetic field city equals H F by M. F is the force, M M per meter. Okay. So, magnetic field, okay. So, already you have seen this one, and if you have coil also, coil will also be producing, let us say electricity conducting, then in this case your flask will be created. Okay. Rotating flask will be created around this. Okay. So, that way you are creating magnetic will create magnetic flux, electric coil also will be creating magnetic flux actually, and both connected properly, it will be creating EMF, or if you are creating generator, it is EMF, or if you are giving electricity, then in that case your magnet will be moving up and down, it will get reciprocating motion, or if you arrange properly, it will create rotary motion, that will be creating motor. Okay. So, motor and generator difference is that generator means you are giving mechanical energy, you are getting electrical energy, that is generator. Motor is that you are giving mechanical energy, in motor you are giving electrical energy, you are getting reciprocating motion or rotary motion. So, in that case you are converting energy from electrical to mechanical, that is motor.